All right, so the next question says we have a toy rocket. So a toy rocket is projected upward from a point O on level ground, and the vertical height is travels can be modeled by the quadratic function. So very important to understand that we're dealing with a quadratic curve here. All right. So in any case, you're thinking of something that is going to be leaving, going up, at some point it's going to return and come back to level ground. So they're modeling it like that, right? So this would have been O, it went up, and then we have height. This is the height. So at some point in time, it's going to go to its max, and then it's going to return. So let us see, right? So we're looking at this. It says where X is the horizontal distance traveled from O, right? So X is that horizontal distance. So we're talking about having the X axis. Understand? The Y axis is like your H, right? So it says here, find the vertical height of the rocket when it is 1 meter away. In other words, when it reaches right here, 1 meter away, what is the height of that? So basically, this is a quadratic, and we're talking about where h of x, meaning the height function, is given by 40x minus 8x squared. So the height function is given by 40x minus 8x squared, right? Now, if we want to find h of 1, because when they say 1 meter away from O, it's like saying h of 1 in your regular function idea. So you want to put 1 where x is to see what distance you will get. So all we're doing here, we're substituting 1 where x is and evaluate this. So we have 40 minus 8, and this lands us 32. So let us look at this. This lands us 32. So h of 1 is 32. And we're talking about 32 meters in context of the question, right? 32 meters. So that's what one we would have gotten right there. The next question says determine the distance from O when the rocket returns to the ground. And we really want to look at the fact that this is our height, yeah? This is the distance from O. The rocket launched, at some point in time, it reached its maximum and it came back. Now, we want to look at the fact that determine the distance from O. So in other words, then, we want to say what. So there are two places when it was at O, and O is referring to the ground. When before it shoots off and when it returned. All right, so we have been looking at case 1 when it was there. So that's like there at 0, and then case 2 when it comes back down. So we're going to be evaluating this. We want to solve this. In other words, then 0 refers to when 4, let me represent it properly first. We talk 40x minus 8x squared. That's it. All right. So the 8x squared, same idea. We have to let this equal to 0. 40x minus 8x squared. And we want to factorize this, right? So 0 is equal to, we could take out 8x, and then we're going to have 5 minus x. All right, so if we take out 8x right there, we're going to have 5 minus x. And then now from that, based on the 0 product rule, yeah, 2 things multiply to give a 0. One of them or both would be a 0. So we can suggest by saying either 8 x is a 0, of which if you divide by 8, then one of the response is that we're at 0. X is 0. That's one solution when it is at the ground. Or 5 minus x is 0. If you solve this by getting the x over there, x is at 5. So we're talking about at 5 meters is the next time when it comes, when it returns, right? So it started here. This is where it started at 0. And then when it returned, right, still on it, it says P is a point with coordinate -2, 3, and Q is a point with coordinates -5, -1. All right, so we're talking about having a P and having a Q right there. All right, so the question simply said, show that the gradient, which is the slope, M, of the straight line that passes through the points P and Q is 4/3. We can simply take out our points. This is the point P, -2, 3, Q, negative that, where this is X. I could say X1, Y1. I could call this X2, Y2. So what we could quickly do is just to calculate our gradient. Now, gradient is given by a quick formula that says y2 minus y1 over x2 minus x1. Substitute -1 minus, so -1 minus 3, and then we have a -5 minus. So in this case, what we have, so we'll have a -4 on top, and these two will turn into a plus. So we'll have -3. And when you break this down, we actually have +4 over +3. So the gradient that we're looking at is 4/3, which would have synced back with what they want us to show, that the gradient is 4/3 right there. All right, is the value of x when h is greatest, and h is referring to when the height is greatest. Think about our quadratic curve. So I'm going to drop a curve on the side here. If I have a quadratic curve on the side there, we're talking about the height. So this would have been our y-axis there. We have x-axis there, right? Right. Right. So this is the y-axis. This is our x-axis. This axis is dealing with the height, and the x-axis is dealing with how far it is from the starting point. Oh, but at any maximum or greatest distance, you are actually on what is called the axis of symmetry. So the axis of symmetry will help us to find our maximum, because the only x value at maximum or minimum is the axis of symmetry. So all we have to do is to find the axis of symmetry. Axis of symmetry is an x value. When we find it and substitute it in the original function, it's going to tell us the height at that greatest, right? So the greatest there, we're able to find that by utilizing the axis of symmetry. The axis of symmetry can be found by this formula. So axis of symmetry, can do more than one things to find it. We could use the 0 and the 5, could add them, divide by 2, or you could use a formula that says minus b over 2a. Hold on. A is -8, b is 40. So the axis of symmetry is an x value, and it is minus b over 2 times a minus 40 over minus 16. And this will give you 2.5. So 2.5. So that's just the axis of symmetry. Also, we could have found the axis of symmetry by taking the two roots. Remember the solutions we got x equals 0 and we got x equal to 5. If we should add them, so in other words, if we should be adding our 0 and our 5 and divide by 2, it can tell us the axis of symmetry just the same, and we'll get the same 2.5, right?